Welcome back. For today's video, we will be looking at the following diagram to the right, which has a rectangle and a curve, which represents the function y is equal to 4 over 1 plus x squared. And the problem is asking what is the area of the shaded region, which is this portion here and this portion here. So let's write an equation that will describe what we're looking for. So the area of the shaded region, area shaded, that's equal to the area of the rectangle minus the area under the curve. So this is the area of the rectangle, this whole thing, and then the area of the curve, we subtract the two and we get the shaded region. So solving for the area of the rectangle is quite simple. We just need to have width times height. The width is just 2 and the height is 4, so 4 times 2 is 8. And then for the area under the curve, we just need to integrate, and we're going to integrate from, we could integrate from -1 to 1 for this function with respect to x, or we could integrate from 0 to 1 and multiply that by 2. And let's go that route because that'll be a little bit more simple, because anytime you can get a 0 as one of your limits of integration, you typically want to do so because it typically makes the problem solving a little bit more easy. So let's go ahead and do that. So we'll say this is equal to 2 times the integral from 0 to 1 of 4 over 1 plus x squared dx. So when we look at this integral, you might be thinking chain rule, but we can't really do chain rule here because we don't have an x in the numerator. So instead we have to look at our trig identities. So if we look at cosine squared theta plus sine squared theta equals 1, and this is just your Pythagorean identity, and we divide the whole thing by cosine squared theta, we just end up with 1 plus tangent squared theta is equal to secant squared theta. Now this 1 plus tangent squared theta looks very similar to this 1 plus x squared theta, and then this is equal to secant squared theta, which is just one term instead of two terms here, which would make the problem a little easier to deal with. So let's go ahead and do that. We can say x is equal to tangent of theta, and then we also want to deal with this dx and change it into theta world. So let's take the derivative of that with respect to theta. So dx d theta is equal to secant squared theta d theta. And I just brought the d theta to the other side. And so now let's go ahead and rewrite the right side of this equation. So this is equal to 2 times 4, so that's 8. I'm just going to bring the 4 outside of the integral. And that's 1 over 1 plus tangent squared theta. And then dx is equal to secant squared theta d theta. So the denominator is 1 plus tangent squared theta, but that's just equal to secant squared theta based on our trig identity. And that's the same thing as secant squared theta above, so we can actually just cross these off. And then we can simplify further. We have 8 times the integral of 1 times d theta, which is just d theta. Now we can't use 0 and 1 because that was from the x world, so we need to change those limits of integration to the theta world. So we'll say 4 x is equal to 0, and then we're going to use this equation, but I'm going to flip it around, so we'll have tangent of theta is equal to 0. So then we take the inverse tangent, and then we get theta is equal to the inverse tangent of 0. And so this is essentially asking for what angle theta do I have the ratio of opposite over adjacent, or the slope value of 0. And on a unit circle, that would happen at theta is equal to 0. So let's do the same thing for x is equal to 1. So we have tangent of theta is equal to 1. Same thing, we're going to take the inverse tangent. And so then theta is equal to the inverse tangent of 1. Inverse tangent of 1, my apologies. And then same thing, we ask ourselves the question, for what angle theta do I have a ratio, or in the case of tangent, a slope of 1? And that happens on the unit circle at pi over 4, or 45 degrees. So we can write these in now. This is going from 0 to pi over 4. And then we have 8 times, and then 1, we take the integral of 1, that's just going to be theta. And then we're going from 0 to pi over 4. And so then this is equal to 8 times pi over 4 minus 0. And pi over 4 times 8, well, that's just equal to 2 pi. And so this is equal to the area under the curve. So our final answer for the area of the shaded region, that's just equal to the area of the rectangle, which is 8, minus 2 pi.